A team at the University of Oxford pulled 25 cremated skull pieces out of storage at Stonehenge in 2018. The bones came from a ring of pits called the Aubrey Holes, dated to around 3000 BCE. They expected to find a local group. The people who built the monument lived next to it and were laid to rest in its base. They didn't. 40% of the bones carried a chemical clue from somewhere over 200 kilometers away. So how did a group of people from West Wales end up cremated, carried, and buried under the most famous stone circle in the world? Nobody was paying attention to those bones for 100 years. They had been dug out of the chalk in the 1920s by a British military officer named William Hawley, working under the Society of Antiquaries. He found them inside 56 shallow pits set in a circle just inside the outer bank at Stonehenge. The pits had been named after John Aubrey, a 17th century history collector who first drew them in 1666. The bones inside were tiny, burned pieces of skull, jaw, long bones, none of them more than a few centimeters across. Hawley collected what he could. He labeled the pieces by pit number, stored them while his work went on, and in 1935 his team reburied the whole collection inside Aubrey Hole 7, sealed under the chalk. Then archaeology forgot about them. For most of the 20th century, cremated remains were thought to be useless to science. The usual tests that worked on whole bone, the ones that could pull DNA, isotopes, diet clues, all of them failed on bone that had been through fire. Heat above 500 degrees Celsius shattered the bone's inner structure. Anything older than the burn was thought to be gone. To understand why this matters, you have to understand what cremation actually does to bone at a chemical level. When living tissue is burned at low temperatures, the carbon and nitrogen in the bone structure break down. Collagen, the protein that holds bone together, is destroyed. DNA strands break apart beyond saving. By the time the body has been in the fire for a few hours, the bone is no longer a living structure. It is what archaeologists call calcined, white, brittle, mineral only. For decades, that was the end of the testing. You could date a calcined bone using carbon-14, but only if some of the original carbon had survived. Most isotope work was off the table. The diet signals were burned out, the movement signals were burned out, the genetic signals were the first to go. Bones found in fire burials, anywhere in Europe, were treated as basically unreadable. They were listed, they were stored, they were not tested. The Aubrey Hole bones sat inside Aubrey Hole 7 from 1935 until 2008. When archaeologists finally returned to them, they did so mostly to count them, weigh them, and rebury them. The first serious new study didn't happen until 2008, when a team led by Mike Parker Pearson at the University of Sheffield dug up the contents of Aubrey Hole 7 to study cremation weights and who the people were. They showed that the pits held the remains of at least 63 people, men, women, and probably children. Almost none of the bones gave up any more clues. What they needed was a method nobody had built yet. That method arrived through a doctoral student named Christoph Snoek. He had a background in chemical engineering and had moved into archaeology through rock chemistry. In 2012, he started a PhD at Oxford under Rick Schulting, an associate professor in scientific and prehistoric archaeology. Schulting gave him a problem that had beaten several researchers before him. Find a way to read cremated bone. The chemistry seemed impossible at first. Strontium, the element archaeologists use to track human movement, sits inside the calcium crystal structure of living bone. In a regular skeleton, the strontium ratio in the bones tells you where a person ate their food during the last decade or so of life. The ratio comes from the rock below, gets taken in by plants, gets eaten by animals, and ends up in human teeth and bones. Each area has its own fingerprint. The problem with cremated bone was that the strontium signal seemed to get ruined. After burial, modern strontium from the soil around the bone could seep into the calcined bone and replace the original fingerprint. The people who tried before Snoek had thought this made any reading useless. This is where the story took a turn nobody expected. Snoek started testing the chemistry of calcined bone himself. He measured what happens to the calcium phosphate structure when it is heated above 600 degrees Celsius. What he found was that the structure doesn't just survive the burn, it forms new crystals. The strontium that was inside the bone at the moment of cremation gets locked in by the heat. The new crystal structure is tight, solid, and almost fully sealed off from the soil around it. In other words, the very process that was supposed to destroy the signal was the same process that saved it. The meaning was huge. It meant that every cremation burial in Europe, from the Bronze Age through the Roman period and beyond, was now possible to test. Tens of thousands of people whose origins had been thought to be lost forever could now be placed on a rock map. Snow's first paper showed the theory. His second paper proved it on test samples. The next step was to use it on a real dig. Stonehenge was the obvious choice. By 2017, Snow had partnered with Schulting, Parker Pearson, John Pouncett at Oxford, and a team at the Vrije Universiteit Brussels, where Snow was doing his postdoc work. The Stonehenge cremated remains were now under the legal care of Historic England and English Heritage. Both agreed to the testing. The team chose 25 people from the Aubrey Hole collection, looking at pieces of the occipital bone, the back of the skull. Thick, well-kept, good for chemical testing. The samples were ground up, dissolved, sorted through chromatography, and run through a mass spectrometer. The machine measured the ratio of strontium-87 to strontium-86, shown as a decimal number. The ratio for the chalk rock under Stonehenge falls between 0.7074 and 0.7090. Anyone who had grown up eating local food, drinking local water, and breathing local dust should fall inside that range. 15 of the 25 people did. Their ratios matched the Wessex baseline. They had lived in the area around Stonehenge for the last decade or so of their lives. Local group, no surprise. The other 10 were a problem. Their strontium ratios ran from 0.7091 to 0.7118, higher than any number the chalk under the ground can make. To get those numbers, you have to be eating food grown on much older, harder rock. The kind of rock that only shows up in certain corners of the British Isles, northern Scotland, parts of Ireland, the Lake District, and one other place much closer to Stonehenge than any of those. To put that more simply, 40% of the people buried under Stonehenge's earliest ritual circle had not been living there. They had been somewhere else. And the chemistry pointed to one best match. The Preseli Hills in West Wales, 200 kilometers to the northwest. The same hills where the Stonehenge bluestones came from. This part is worth paying attention to because the detail would come back later in a way the team did not expect at first. The bluestones at Stonehenge are not the giant sarsen pillars most people picture when they think of the monument. The sarsens were quarried about 20 kilometers north from local English stone. The bluestones are the smaller inner ring. They weigh between 2 and 5 tons each. They were dragged, rolled, or floated more than 200 kilometers from quarries called Craig Rossifellen and Carn Godog, both in the Preseli range. For most of the 20th century, the bluestone move was thought of as the most amazing planning job of Neolithic Britain. Nobody really thought the stones had moved themselves. But the question of who had moved them and why had no good answer. The common story was that local Wessex chiefs had run the project and paid for it. The Welsh part was the rock, not the work. The bones in the Aubrey holes now showed something different. The Welsh had not just sent stone, they had sent people. And those people had ended up cremated and buried next to the monument they helped raise. Snow and his team didn't stop with the strontium. They also looked at the carbon and oxygen isotopes locked in the calcined bone. Those fingerprints come from the fuel that was used in the cremation itself. The wood that burned the body leaves a mark in the bone as it heats up and forms new crystals. The usual Wessex setting is open, chalky grassland with a few trees. Trees grow in scattered patches. The carbon fingerprint shows an open canopy. The fingerprint inside several of the bones from far away was the opposite. Thick woods, the kind of closed canopy forest that grew, in the 3rd millennium BCE, in the wetter and more protected valleys of West Wales, which meant the bones had not simply been those of Welsh migrants who came to Stonehenge and were buried there. They had been people who were burned in Wales, packed into urns or skin bags, carried over land for at least 200 kilometers, and then left at the foot of the Bluestone Ring. Some of them might have walked the way while alive, raised the stones, and never returned home. But several of them had clearly been buried as ashes, brought as cargo by mourners who chose the monument as their final resting place. That conclusion, pulled from 25 pieces of skull, is what the Snow paper actually said when it was published in Scientific Reports in August 2018. If you're still with me, hit subscribe. The second half of this video is where the science gets harder to ignore, because what came out of Harvard 6 months earlier turned the Stonehenge bones into evidence for a much bigger argument about who actually built Britain. By February 2018, just before the Snow paper went to print, a separate team in Boston had been working on a totally different problem. Inigo Olalde, a young gene scientist in David Reich's ancient DNA laboratory at Harvard Medical School, had been reading the genomes of hundreds of ancient Europeans, taken from skeletons across Britain, Iberia, Central Europe, and the steppe lands east of the Black Sea. The goal was to track the spread of a single archaeological culture called the bell beaker, named after a special shape of clay drinking cup that began appearing in graves around 2750 BCE. The bell beaker question had been argued for over a century. Some archaeologists believe the pots traveled without people, spreading through trade and copying. Others believe the pots traveled with migrants. The DNA could finally settle it. When the Olalde paper was published in Nature on February 21, 2018, it settled the argument for good. The pots had traveled with people. And the people had arrived in Britain in numbers nobody had expected. According to the genome data, the bell beaker migrants entering Britain after about 2450 BCE replaced about 90% of the current British gene pool within a few hundred years. You'd think of finding that dramatic, the almost complete gene takeover of an entire island within 5 or 6 generations would have stayed in the headlines longer. It didn't. Almost no one heard about it, but the meaning for Stonehenge was immediate and impossible to miss. Up to that point, archaeologists had treated Stonehenge as a monument built by the people who kept on living in southern Britain through the Bronze Age. That idea was about to flip. The Aubrey Hole burials, the cremated people from West Wales, the local Wessex farmers buried next to them, they were all part of a group that no longer existed as a single ongoing gene line. They had been wiped out as a group by the Beaker migration. Their descendants, in a strict gene sense, do not show up in any later British group. The monument they had built stayed standing. The people who had built it did not. Parker Pearson had been working on the bluestone quarries themselves at the same time. His antiquity paper on Craig Rosie Felon in 2015, followed by a 2019 paper adding Carn Godog, dated the active quarrying between roughly 3500 BCE and 2900 BCE. The busiest window of quarrying matched almost exactly with the time when the Aubrey holes were being cut at Stonehenge and the cremated people were being buried. Parker Pearson's reading, stated across both papers and in later interviews, was direct. He said the matching dates between the quarrying and the burials showed that the Bluestone Move and the funeral march were one event. People in West Wales had quarried the stones, walked with them to Wessex, and stayed long enough to be buried there. Some had been cremated and buried in the Aubrey holes. Others had carried the ashes of family who had been cremated in Wales before the journey began. Stonehenge, in this reading, had never been only a local monument. It had been a meeting point between two groups at opposite ends of the British landmass. The paper itself admitted a limit. The strontium ratios in the 0.7091 to 0.7118 range match not only West Wales but also parts of northern Scotland, the Lake District, and parts of Ireland. The team named West Wales as the most likely source because the bluestone tie made it the simplest archaeological reading. Without that tie, the chemistry alone could not have pinpointed the source. Now, the team could have stopped there. They didn't. The next phase of their work, which is still going on, is to use the Snoek method on thousands more cremation burials across northern Europe. Belgian Bronze Age cemeteries, Roman cremation sites in Britain, Iron Age burials in the Netherlands. Each one of them, for centuries, had been thought unreadable. Each one of them now has the chance to give up the origin of the people inside. Pay attention to this next detail, because it explains why the Stonehenge finding lands with the weight it does. Most prehistoric monuments have been studied by reading their architecture. The shape of the stones, the way the entrances line up, the size of the rings. The architecture tells you something about belief. It does not tell you about the people. The Snoek method for the first time lets the cremated bones speak directly, and the message they gave out of the Aubrey holes was clear. It said the monument was built by a group that covered at least a fifth of the entire length of Britain. It said the bluestones did not arrive alone. It said that the funeral practices, the cremation rituals, the choice of burial site, were planned across regions the textbooks had treated as separate. That planning is what changes the rest of the Stonehenge story. The monument was built in phases. The Aubrey holes were dug around 3000 BCE. The bluestones were raised, moved, set in new places across several centuries. The giant Sarsen circle, the part most people picture, was put together around 2500 BCE. The site was changed again and again until at least 1500 BCE. Through all of those phases, the group that kept it going was able to do the kind of long-distance planning across generations and regions that has been given credit only to civilizations that could read and write. Stonehenge was built by people who could not read or write. They could, however, plan a march of mourners across 200 kilometers of forest and chalk, carrying the cremated remains of family to be placed inside a monument they had together quarried, moved, and raised. For a culture once described in standard British school textbooks as basic farmers just trying to feed themselves, that is a level of social planning most modern logistics companies would struggle to match. There is one more detail that matters here. When Snoke and his team picked the Aubrey Hole bones for testing, they chose 25 people from a larger sample that included at least 63 known cremations. The choice to sample only 25 was based on how well kept the occipital pieces were and the material on hand for chemical testing. It seemed normal at the time. It wasn't. The other 38 people were never sampled before the Ministry of Justice license made the remains be reburied. Their material went back into Aubrey Hole 7 around 2010, untested for origin. Which means that the 40% from faraway number, the headline number from the 2018 paper, is based on a sample that has not yet been expanded. Whether the share stays true across the full Aubrey Hole group is not known. It could be higher, it could be lower. The next round of sampling, planned under the Belgian project that Snoek now leads at Vrije Universiteit Brussels, will test that question directly. As of the most recent published news, no expanded results have come out. So here is where the evidence currently stands. Of the 25 cremated people tested from the earliest phase of Stonehenge, 10 of them grew up somewhere 200 kilometers from where they were buried. Their wood fingerprints match Welsh forest, not Wessex grassland. Their burial date matches the quarrying of the bluestones at Craig Rossi Felon and Carn Godog. The Bellbeaker migration replaced their entire gene line within a few centuries of when they were buried. The monument they helped build still stands. They do not survive in the living British group at any real share. The Snoek method has now been tested and proven against modern cremation samples in a 2024 follow-up paper published in PLOS One. The method is solid. The Aubrey Hole result can be repeated. The reading that the bones were Welsh is the strongest reading given everything else we know about the monument. What we do not know is who, exactly, those 10 people were. Whether they were priests, quarry bosses, top leaders, regular workers, or the cremated relatives of any of those groups. The strontium tells us where they ate. It does not tell us why they were chosen for that burial, or what part they played in the building of the most studied prehistoric monument in the world. What survives is the bone itself. 5,000 years after the fire that should have wiped them out, pieces small enough to fit in a coin purse are still readable. The chemistry that the original mourners would have thought of as destruction turned out, by accident, to be saving. The structure that locked in the strontium signal at the moment of cremation has held that signal across thousands of years of frost, flood, plow, and digging. It survived being collected and stored briefly by Hawley's team before being sealed back into the chalk in 1935. It survived the idea that it could not be read at all. The Aubrey Holes are still there. You can walk around the outer edge of Stonehenge and see the chalk markers that show where the pits used to be. The bones themselves have been reburied in Aubrey Hole 7 since the most recent dig. They are sealed back inside the chalk under the same stones they were meant to honor. What changes every decade or so is what we are able to ask them and what they are able to answer. The next round of testing, planned for the late 2020s, will probably add more places to the map. More routes, more travelers, more proof that the monument was the work of a network, not a tribe. The story of Stonehenge stops being a story about stones at that point. It becomes a story about a group that planned itself across distances that historians have spent 2 centuries thinking were impossible. The bones do not lie. The fire did not wipe them out. And the chemistry written in calcium and strontium and carbon has been waiting under the chalk for 5,000 years to be read. The next reading is coming. If you want to see more deep dives into the forensic side of ancient archaeology, hit subscribe. The video on screen breaks down another bone study that put a Bronze Age traveler thousands of kilometers from where archaeologists thought he had any reason to be. Click it.